Prompt engineering isn't enough. Most AI builders focus on crafting the perfect prompt, hoping one shot will solve complex problems, but real-world applications need intelligent workflows. Today we're exploring how orchestrating multiple steps, not just individual prompts, can transform your AI systems. Whether you're building content tools, assistants, or decision engines, this will change how you think about AI architecture. It's called flow engineering. Welcome to episode 35 of Tool Use, the weekly conversation about AI tools and strategies to empower forward-thinking minds. I'm Mike Bird, along with Ty Fierro, and this week we're joined by Minki Jung, an AI engineer and the author of the Agile Manifesto for Flow Engineering. Minki, welcome to Tool Use.
Thank you. Thank you for having me. I'm so excited to talk about the flow engineering.
Yeah, super interested in flow engineering. Let's start off by kind of talking about your background and how you got to this space and how you got interested in AI.
Yeah, sure. So I majored physics and philosophy at university, and I actually wanted to be a philosopher of science. But then I actually pursued my master's a little bit, but it was too like esoteric, and I was wondering, learning about this philosophy is beneficial for the society. And then I had a chance to work as a newspaper journalist at the time. So I took the chance and I kind of learned how the world is. And I interviewed a professor who was an AI lead of AI conference lead in Korea, South Korea. And he kind of gave me the vision of the future. And I was thinking, wow, this is like really changing the whole industry. And that was in my mind. And I immigrated to Canada in 2021, and I started learning AI and full stack engineering. And yeah, basically after that, I just built my applications, LLM application on my own. So over the 1.5 years, I built like 7 LLM applications, exploring different tools, different frameworks, different methods, and basically learning on my own. That was my journey.
Very cool. And actually, Minki and I met at AI Tinkerers Ottawa, where he had just done a project, and I firmly believe the best way to learn is just by doing, experimenting. You actually get to see how it works. But would you mind giving the audience an overview? What is flow engineering?
Yeah, so flow engineering, this term was coined by Andrei Karpathy about a year ago when he saw Arpacodium, which is a novel way to do code generation. So before Arpacodium, what people did is they prompted a long instruction and just called LLM just once. But Arpacodium has broken down into multiple steps and also added like a test iteration and so on. So it improved the performance in a great deal. And Andre Karpathy said, "Oh, this we can call this flow engineering, similar to prompt engineering." So it's calling LLM in multiple times, but importantly, it's a predefined steps. So you can kind of compare flow engineering versus autonomous agent building. So autonomous agent is you're building more abstract agent cognitive architecture, but flow engineering is more about nitty-gritty workflow engineering. So it's very hard coded, but inside there is some LLMs are doing some jobs.
Interesting. Okay. So I feel like workflows are very important for like specific types of jobs. Where do you think workflows shine best, and where could like AI agents perform better?
Yeah, actually, like Anthropic released a blog post about like when to use autonomous agent in workflow. But like I would say simply for vertical applications. So if your job, if your task is very well defined, and you repeat that workflow, you repeat the steps multiple times, and then like workflow is better. But if you're handling like diverse tasks that is so different, requires different input, different output, and different steps, then autonomous agents is better. Also, there is some benefits and like pros and cons in workflow versus compared to autonomous agent, which is when you have a workflow, you can iterate faster, you can add features much faster, and you have more controllability because you know which part of the step is not working, and you can go there and then fix the prompt, or you can tweak the steps in a way that it works better. On the other hand, autonomous agent is you're building more. You're working on the higher level. So you're building like a loop. You have a reflection. You have a React agent and so on. But it's not when something goes wrong, it's really hard to kind of maneuver that. It's really hard to change the behavior of the agent.
Vibov from BAML actually said something very similar, where the more interactions you have, the more granular control you have. It just gives you more levers and knobs to really play with the output to get the desired you want. Could you give us some concrete examples of when you should not use LLMs and when hard coding a process will usually result in better outcomes?
Yeah, so one other benefit of workflow is you can have non-LLM nodes, if you will, and LLM nodes. For example, when you have to format the data, format the input in a better way, or when you calculate some numbers, then using LLM is not an ideal way to do that work. So you can just use Python code to do that.
Staying on top of AI news shouldn't mean endless scrolling. Anetic Daily Intelligence is a free daily report uniquely curated just for you, like a personal assistant updating you on exactly the AI news you need. Every report is unique to each reader and continually adapts based on your feedback, keeping you ahead of the curve on the topics that matter to you. Sign up now at anetic.co.
Interesting. I mean, Python code is very flexible. What are some of the kind of the tips you'd recommend for getting started with workflows? I mean, I've kind of built some workflows before, and I feel like either they're too rigid or maybe they're maybe too flexible. Do you have any pointers as to how to build the best workflows?
Yeah, so in my workshop at AI Engineer Summit, where I talked about flow engineering, I actually went back to history. So I actually look into Henry Ford, how Henry Ford revolutionized the automobile industry, because there are like four takeaways that I can get from Henry Ford. Like first is you have to be obsessed with decomposing tasks. So when your workflow is not working well, it's too rigid, you might decompose a task in a wrong level or in a wrong architecture or a topology. So you have to iterate the workflow and see how can we decompose the complex task into an optimal level and optimal flow. And secondly, if you look at like Henry Ford factory, he was obsessed with building a workstation for the workers. So let's say you're cutting the wheel of the vehicle into half, and then you mentioned later. So you have a wooden wheel, and you have to cut it into exact half. And Henry Ford designed the workstation in a way that you just simply put the holes into the peg, and then it's simply you push the rail, and there's like a machine that cuts the part, the exact cut. So you don't have to measure it. You don't need any knowledge how to do sawing. It's all all the skills are engineered into the workbench. So similarly, when you build workflows, you need to engineer some of the skills that LLMs can do into the workflow. For example, LLMs are not good at like taste or judgment. It's hard to align them. You can of course fine tune LLMs to do it more better, but it takes time and cost, and it's not perfect. So you can embed that into the flow, having criteria, and ask LLM to whether or not the output meets the criteria, and then you iterate that multiple times. Then you can have like a good judgment system. Lastly, Henry Ford famously like limited the color of the car to black, because having many colors of car will make the process too complicated. Similarly, when you do workflow like flow engineering, you might be tempted to achieve very novel or complex tasks, but you have to first start with really simple task that handles like 90% of your job. For example, you're planning a trip. You're going to assume that this person is going to accommodation right after they landed to the terminal. that will simplify the process. But not everyone goes to the compilation right after they land it, right? But we can kind of modify the final outcome to make the workflow flow better.
This is great. I love taking inspiration from successful manufacturing techniques in the past and applying the world of atoms to the world of bits to try to figure out more efficient ways of doing this. A lot to unpack there, but I just want to start with the first point you brought up, the decomposing tasks, and mentioning how you can do it incorrectly. Do you have any strategies for how people can work with a given problem to try to break it down to a good decomposition?
Yeah, so first of all, decomposing, I found that it's extremely hard to formulate because tasks that like we're trying to automate is very diverse. So some tasks are can be parallelized easily. Some tasks cannot be parallelized. It's more like a dynamic. So I can't give like concrete rules, but I've come up with this 7 steps. So I used to work at the government of Canada, and I've seen so many like struggles when they're building these AI applications because they didn't have these steps. So this is I got inspiration from there. So step 1 is first simulate the task that you're trying to do. So with humans without using AI. And you have to, so you have an observer and you have an operator. An operator is doing the task. For example, it's the planning. Let's say it's planning a trip. Then and this person do the task, thinking out loud, and the observer observe how this person actually complete the task and write how-to steps. And then the second step is you have to test the step. So without complete the task only following the how-to steps you've written. And you will find something missing. Oh, I didn't consider this. I didn't it should be the steps are wrong or something like that. That's step 2. And step 3 is decompose overloaded steps. So let's say you're planning a trip and the first task is come up with good place to go. And that's too general, right? Come up with place to go is you when humans do the task, you need several steps to do that. So you first have to recognize the client's taste, and then come up with search queries for the like Google or Perplexity, and then do the search, and then summarize the result, and so on. So you have to decompose overloaded steps. And step 5 is embed working memory into flow. So LLMs are stateless. Whenever we call LLM, we have to curate the memory in the prompt. So when you have this how-to steps, you have to embed the memory into kind of state variables. And step 6 is parallelize if you can. And step 7 is examining what steps really require LLMs. So you might over-engineer the steps. So you really go through the steps and see what steps we can just use traditional programming.
That's actually that's super fascinating because I used to work at a public health lab back in the day, and we used to make new protocols for experiments. And the way that we did these protocols is we write out the way, like one person would write the whole workflow out, and then someone else would try to go and do the workflow. And we noticed more often than not that, if you just give someone a blank piece of paper, it makes sense in your head, but it probably doesn't make sense in their head. So this first step that you have of like, watch someone actually do the thing first and kind of like get those like endpoints. That makes a ton of sense. When is it best to like split a workflow into multiple workflows, or is it kind of best to just have one giant workflow that kind of handles most of the tasks?
Yeah, so I would prefer to have one workflow for several reasons. First, it's extremely hard to manage the context between different workflows. It's like same for humans. When you collaborate, you have to have meetings every week, every day, and you have to share what you've done, and you have to discuss about the direction. When you have a separate workflow going in parallel, and you want to achieve one specific goal, it's extremely hard to manage context well. But so there's some tasks that can be done in this way. For example, if you want to do some research and you want to do research about in North America and South America and Asia, then those tasks can be separated easily. But most cognitive tasks require some kind of information exchange. So I prefer to stay in one workflow. One thing that I keep observing is that marrying workflow and autonomous agent. So, it's not actually, you can combine them because in the workflow, there are loops that is like an autonomous agent, a React agent that has max iteration count, and then it does some task until it is like satisfied.
On that note, actually, when you're building your AI projects, do you have a go-to LLM framework that helps integrate into your concept of flow engineering, or do you just like freestyle it yourself?
Yeah, I love LangGraph. I've tried CrewAI, AutoGen, and like different frameworks, but those frameworks were too high level. I need to go really deep, and like I need to be able to tweak the prompt and the way that I store state variables and the way that I reduce the state variables and so on. So I'm a big LangGraph fan.
I feel like the graph-based mechanism kind of makes sense for the workflows. You have the edges and the nodes. Makes a lot of sense. I like
Yeah.
LangGraph a lot. LangChain's okay, but LangGraph is fantastic. How do you choose what LLMs you use for particular steps? Is there a system that you use to decide which LLM goes in which LLM step?
That's a great question, and I actually wrote a blog post about it. So basically, what I'm doing is I just know what the task is, right? If the task is simple summarization, then I just use like GPT-4 or GPT-4 is kind of expensive, so I use like Cloud Sonnet, Cloud Haiku. Yeah, but if it requires some reasoning, I use reasoning models. If it is in between, like use Cloud 3.5 Sonnet. It's all Vive actually. So ideally, we need an evaluation data set that we can try different models and see which model performs the best. The tricky part is since we're not evaluating one LLM call, but multiple steps. So there's like a local maximum and like a global optimal path, right? So you have to try different combination of LLMs to achieve the best outcome. So that's one problem, and I think DSPy came up with an algorithm to do that, on a prompt level. But there's another way to do that, which is using automatic LLM router. So have you heard of Not Diamond?
Heard of them, but would you mind explaining a bit more?
Yeah, so Not Diamond is the state-of-art LLM model router. So you just put the prompt, you send prompt to the LLM router API, and it returns which model is the best. And you can set like which models you have at the moment. I've tried it, and it reduced the cost and rate latency like 50%. But the problem is it's still routed like summarizing tasks to Cloud 3.5 Sonnet. That task was very simple summarization task. I would use Haiku, and I had no problem with that. But it kept using that, even though I set like the parameter to like a cost efficient. So so I think those router providers can never train their routers with all possible prompts and outcomes. And because, basically prompt is English, and English can be anything. You can put anything. There's so much entropy there. So ideally, you need to train your own router using your own model, and you have to do that on your own. So having evaluation data set is so important here again.
Yeah, evals are something that are definitely underutilized. A lot of people talk about it, but few people actually do it. Do you have any strategies on either creating that testing data set or just evals in general? Any advice for people who are at the start that want to implement it?
Yeah, so I would say I'm not an expert here, but I'm a big fan of Hamill's blog post.
Yeah.
He wrote a great blog post that I like read like 3 times, and I sent it to all my colleagues and so on. So first of all, like the problem with eval is you wouldn't have unless you have a customer, unless you have a product that has customer, you wouldn't have like a real data set going in. So you don't even have data set to test. You don't have a prompt to test. Like outcome, annotating outcome is another story. You first need the data. So what you can do is you can use LLMs to generate this test data set. LLMs are pretty good, like it's a synthetic data generation. But you have to be careful to make the synthetic data diverse and cover all the business logic that you want to do. Yeah, that's one thing. And annotation part is basically, if you want to create a good annotation, you first have to have a what good result would look like. Like most team don't have like clear. They might have a like unconscious knowledge, like tactic knowledge, if you will, about what good output would be. But the problem is you have to delineate it so that LLM can judge it, or you can leverage, you can scale it up. Otherwise, you have to do it on your own. So it's important to come up, discuss about what's the good, what are the criteria, what is the criteria of good output. You have to first figure that out, and then build like an internal application that you can simply annotate every day with all the team members. So I think that's really valuable.
Wow. I asked this to a couple other people before, but I'm kind of curious what your thoughts are on like what are your best pro tips for prompt engineering? And it seems like every AI engineer has a different answer for this. And every time we ask this question, we get such interesting results. So I'm curious how you approach prompt engineering and kind of your do's and don'ts.
Yeah, I love actually prompt engineering. I think prompt engineering is understanding LLM, treating LLM as a person, not a machine. So the difference between machine and person is when machine doesn't work, you just like get frustrated. Because there's no communication. It's not iterative. It's like you work, it works or not, it doesn't work. But humans, it's like when intern didn't do what you asked, it could be frustrated, but you have some room to, okay, this is not right. What I meant is this. Go back and do it again. If you have that mindset and then really believe in LLM's capability, then it's much better when you just like frustrated or you just like attribute the LLM's fault to their limited capability. So for example, LLM responded wrong, like hallucinated. And then you think, okay, this model hallucinated. You can stop there. But then you can go one step further by going into the LLM's input, the actual LLM call. So you have to have an observability tool like Langsmith or Phoenix, Arise, and so on. You have to go there and then read the prompt. Really, not many people really read the prompt. When LLM hallucinates, you read the prompt and you realize, oh, I forgot to put my function parameters. If you don't put function parameters, it'll hallucinate the function parameters, right? So that's the thing, like you have to believe in this technology. You have to believe in that capability, then you can get more out of it. And that's like an attitude attitude that you can have. Another tip is I'm really obsessed with making prompt more ergonomic. So if you go back to the Henry Ford workbench, Henry Ford designed this cutting saw workstation in a way that the worker doesn't have to put this cut wheel frame into the slide, and it just flow like a slides out to the next worker. You don't have to move your lower body at all. So the workstation was built really, really ergonomic, and it's like it handles errors because it's built in a way that it cuts the part precisely. It's similar to LLMs. You can design the prompt in a way that LLMs can only focus on the task. You can design the prompt that in a way that LLM wouldn't deviate in a different ways. It's actually similar to how humans interact. When you give instruction to your colleague or your some people, uh, you want to emphasize something because the person might miss that, or you want to not add unnecessary information there because it would distract or distract them. But the problem with LLM is when we give bad instruction to colleagues, they're humans. They can ask back to us and then ask follow-up questions. But LLMs don't ask follow-up questions unless you have like a RL trained model. So they do the best that they can do. So it's our job to actually go into the prompt and figure out why it kind of understood in that way. Yeah, that's my 2 tips.
Oh, the great insights. We had a guest on previously, Jason, and he would actually spend more time editing existing prompts rather than carrying the conversation. Similar to what you said, if the LM makes a mistake, it's the issues in the initial instructions, not in, let's follow, because then it has all of this extra context that could steer it the wrong way. Have you found that you can improve this skill? Because I do believe it's a skill to be able to prompt sufficiently. Can work just by going to open like ChatGPT or Claude and have conversations and kind of see where it goes? Or do you feel there's more value in just building projects and actually seeing an outcome in a given regard and then edit in that way?
Yeah, it's a great question. I have so first of all, humans behave differently when they have different environment. So if you want to make your engineers do better prompt engineering, you have to give them better observability tool. Without observability tool, you can't make a good prompt. You can't go back to the prompt. The more pain it takes to look at the prompt, the less likely you will do that. So first, make a good environment, lower the pain to look at the prompt. And secondly, this is an easy trick. And it's actually not mine. It's Anthropic team's suggestion. So copy the prompt and ask Claude or ChatGPT if there is any ambiguous instruction there. So ultimately, the task LLMs will do the test, right? So if you ask what's the missing information, what's ambiguous, and you get their response or feedback, and if you address that, it will help the prompt work better.
Excellent. Great advice. You've been mentioning some awesome resources like the Anthropic team's Hamel's blog. Where do you get your AI information and these tips and tricks that you learn and can apply?
Yeah, that I actually talked to this about with my colleague yesterday, and I have some kind of preference, and I'm very kind of strict about it. So I found a lot of people in AI space are distracted with new trends or new topics that's coming up on Twitter, YouTube, any kind of social media. And then since it's not stopped, it never stopped. So never new things coming up and up. So what people end up doing is they just keep following these things, not learning the core skills or not going deep enough so that you can keep that knowledge when new technology comes up. So in this field, it's moving so fast. You have to at least go a certain level of depth. Otherwise, what you've learned will be obsolete in one or 2 years. And why the new trend is trendy, understanding why new trend is trendy, will depend on how much knowledge you have on this AI. For example, if you don't know about transformer architecture, you wouldn't have a better understanding why rag or rag versus long context window, that discussion. If you have better understanding at the architecture level, you can have some opinion, your own genuine opinion, rather than swayed by this social media trend. So I abstain from looking at social media. I subscribe trusted blog post writers. So Hamel or some Substack newsletters, I subscribe that. and then get that from my email and only check the email. And then I read the blog post. And one more thing. I'm a true believer that there's no way to there's no shortcut in terms of learning, because the time you spend on learning matters. Let's say you read a book, you read a summary of the book. Even if you have all the information in the summary of book, you end up spending less time, and that affects your brain lesser than reading the whole book. The book is very repetitive, but the repetition helps you internalize the knowledge. So I prefer long content, which is I think I would love to read books, but I read O'Reilly books, but it's moving so fast. So blog post is the right medium, I think. And then from blog posts, they're mentioning some academic papers, and I read those papers, and from the paper I go to another papers and so on. So I read papers and blog posts. That's main source.
Actually, a really good point about the social media, the shiny new toy syndrome. You know, you see new models coming out or new frameworks and want to go try it. I'm guilty of this. I love seeing new tweets and just diving right in, and I'll jump into the docs. I'm like, wait a minute, what am I doing? And it's kind of interesting too, because I taught myself how to code, and I had a very similar experience with shiny new toy syndrome when I was learning to code. I was like, okay, well, I'll learn Python, and now actually I should learn JavaScript. I'm going to learn React. I'm going to learn Tailwind. I'm going to learn all these different tools because I learn about new tools. But I eventually just stuck to one stack and then started building projects in that one stack and got way better at coding than jumping around the different things.
Yeah, I think there is a value of that too. Like I sometimes just scroll Twitter and just randomly try some models or so on. And there's some value there. But I think it's not efficient. Like the most efficient way is focus on your learning, and then once the trend, you let the judge the public. So once something becomes trendy, you wait and then see how long that trend endures. And then if it endures, then you can start from there. It's not late, even if you start that late. Yeah.
It's kind of that way with MCP too. It feels like where MCP was I kind of came on the scene with that's interesting. And then you started to see actual bigger companies adopt it, and more people start using MCP. And now I feel like it's a time you can actually start paying attention to it. Okay, I'm curious. It sounds like you were someone that did a lot of self-teaching yourself too. And I taught myself how to code. Do you have any tips for people on how to self-teach themselves best? Because I feel like there's so many people right now just jumping into code with Lovable and Cursor and trying to learn as they go. I know it's not easy, but it's probably, I love learning myself. And I'm curious if you have any great tips on project learners.
I would say, so there are two things. First, optimizing your body is so important. It's ultimately your body is learning, your brain is organic. You have to optimize your body. So wake up at the same time, go to bed at the same time, not using blue light until sleep is so important, because when you're sleeping, you're synthesizing what you learn. If you didn't sleep that day, what you've learned, most of them will lost. So you have to really focus on your sleep and learning. Human attention span is 90 minutes. So I tend to just take a break after 90 minutes rather than just keep going on. It's more efficient. Even if I took the break, it's more efficient to take the break because your attention matters. So those are a first thing. I'm a big fan of Andrew Huberman or those, I actually did the Brian Johnson's lifestyle for a year, and I used to have a lot of gray hairs and it's all gone. And I've been slacking off a little bit and it's coming back again. Yeah. But I really got the benefit from optimizing my body. It was my productivity goes almost 5x. And that means you can spend 20% of the time and they get the same effort, same effect, right? That's the first thing. And second thing I recommend is it's good. People know that you have to build. You have to actually use code. You have to write code and you have to actually experience things. But that's important. But that's one thing. if you want to really learn from this experience, like write about it, write a blog post about it, and then kind of extract some lessons or go deeper into some question that you wanted to answer. For example, I was building customer survey chatbot agent, and it turned out it was a really hard problem because I didn't want to have like a predefined questions. I wanted to let AI LLM decide own questions in based on the context. So, but how are you going to come up with a new question? So I was a journalist, and when you guys ask questions, it's very organic. You ask some questions relate to the previous question, you comment, and then you sometimes dive deeper. You have to ask follow-up questions, so on. So I learned that like building AI, and most of this are judgment. Like it's in like our judgment as a like journalist. I grew that taste. I learned how to ask good questions, how to react better. So it's really hard. I realized, AI are missing this. LLMs are missing this. So that lesson lasts until now because LLMs are still not good at judgment and like taste. So that's the second tip. Like after building something, internalize the project on your own language by writing a blog post.
I love that approach. And I think it's so true because one of the best ways for me to learn something is teach it to someone else. It obviously points out your blind spots, it points out your gaps in knowledge and helps fill it in. So say that someone wanted to, they had an idea for something, this new cool project to do. Would you recommend that they try to like pump the brakes, think it through, or just build the prototype and experiment that way? Or is it varies person to person, but what would Minki do?
Yeah. Like I totally like I recommend that because it's not about how many projects you've done. It's not about how fancy your project looks like. Ultimately, what matters is your knowledge, what you can talk about in the interview if you want to get a job, or what you can build if you want to start a company. So really focusing on the first principle, like learning. If you want to, you may want to stop and pause and think about the question, and maybe like start deviate this project a little bit. But ultimately, the balance is important. At some point you have to want to finish a project and then kind of publish it and share with people, get some reward so that you can start a next project. So like Sam Altman said, great researchers are good at balancing laser focus in the current like short term and thinking in long term. So they alternate that. Like the most of the time they're working on what they're working on at the moment. But sometimes they step back and think really further and then change their direction. So yeah, that's very important, I think.
On this notion of long term, is there anything in the AI space that you're excited for the next year? Is there any kind of technologies that you think are coming down the pipeline that really have you excited?
Yeah, there are two things that comes into mind. First is memory. So I think there are like the bottlenecks when I'm building LLM application. Bottlenecks are two bottlenecks. The important is judgment and memory. Like memory, we can always emulate memory by putting information into context. But even if you have a 2 million, 10 million context window, that's different from our organic memory because our memory is synthesized. We live and we sleep and we prune irrelevant information. We make some dots. So our memory is very organic. That's really hard. That's really sometimes a lot of the tasks require that memory. But it's really hard to emulate that with LLM because it's fundamentally different. One way to do that is like a post-training with the new data set, but that has like many problems like catastrophe forgetting, or it's not really working well at the moment. Another way is using, basically managing the memory using AI. For example, company Letta, they're using LLM to, so when new message comes in, it's a chatbot, and new message comes in, the LLM memory manager kind of categorize it and put it into right certain directory, and when check if the previous information contradicts with new information. If it does, like fix it. Sometimes like there's sleep phase where you kind of prune information and recategorize in a way that it's more efficient. Yeah, that's kind of different from how human actually do memory, but I think it would be sufficient for certain tasks. So the first thing is memory, and second thing is RL, like reinforcement learning AI. So I was deeply like immersed into flow engineering, like workflow design. But the one thing that I learned from AI Engineering Summit is that like deep search from OpenAI, they have an interview with Sequoia, and they said these hard coded workflows are often fails because it's not flexible. If you really like launch that workflow to really like a diverse public, it wouldn't work. It requires only does certain things. So they train the model from end to end with using reinforcement learning. I think this is a great way to kind of add new capability to LLM using that reward learning. But yeah, that's my to-do list that I want to experiment.
Excellent. One thing that just kind of popped in my head, think about the interface between the LLM response and your deterministic code in the workflow, like that connector. A lot of people use structured outputs. Do you have any thoughts, best practices? How do you how do you deal with like the LLM output and then going into your deterministic system?
Yeah, that's really important part. And the way you do that really if you do it right, it will shine when your application when you scale up that application. You might not see like great impact at the moment, but if you want to scale up, you have to make sure. So first of all, I use LangChain ecosystem. So I use the LangChain method called with structure output, and it has multiple ways. Like you can use function calling, you can use structured output. So I mostly use function calling, but sometimes I know that it's like the performance degrades a bit because function calling is not meant to be used like that. Like for example, I don't use the function calling for literally calling function. I use it for extract information from some text or something like that. But it's working right now. I want to explore more other structured output frameworks. But it's all same, right? You define PyDenting model if you're using Python, and then you pass it to the LLM, the orchestrator, for example, LangChain with certain method, and the LangChain put this PyDenting model into function calling thing. And if you call OpenAI LLM, OpenAI put that into prompt and then generates the output. So. And importantly, you must have a fallback models because some of the time it fails. So having fallback models, when I have a fallback model, I first try with the same model with low temperature, and then I try much better model, bigger model, larger model, and then I finally use reasoning model. And if you have like these 3 steps, it's like 99% it works. But it takes more time. It has a latency issue. Yeah, I want to address this issue more like systematically using evaluation data set. But yeah, that's currently how you do it.
All right, one last question for me. Is there anything in the AI space right now that you think is overhyped? Kind of a weird question, I know.
Yeah, I mean, I personally think like everything is overhyped. But let me pick one. Yeah, I think vibe coding is overhyped. Like I didn't really look at the detail even. Like I just like vibe coding. It doesn't really work unless you have the knowledge how programming works and you know how to like guide the model. And like by the way, I have a blog post breaking down boat.new, boat the website generator. And what they're doing at the moment, I'm not sure about not right now, is they basically have a long message history with the long system prompt. So in the system prompt, it asks, you're like a website web developer. You think systematically, you think holistically, and you use this cloud artifact so that we can parse that. So you have a code, you have a edit file tool, and so on. And whenever you like LLM generate code, it goes into the prompt, the message history, and it keep piling up. They didn't even have like a summarization tool. It just goes up until you reach the context limit. That worked really well because you didn't have to have a like workflow design, but that has limit. You can't steer that. You can't once you have a long message history, you're gonna miss something that has happened at some moment. So yeah, I think vibe coding is similar to that. Like you're just keep adding things into the context that you're not aware of, that you're not designed. Yeah, but I think like, so for those who want to build like stereotypical website, for example, our company has like customer, we have to like manage customers, and we want to make a customer dashboard. That's like pretty well defined concept, and like there are many examples building those like customer management system. In that case, like vibe coding is a great way because it LLM already knows, and it's not that once you build it, you wouldn't need to manage it. But yeah, but the problem is also like once you build it, you have to manage that project. You have to keep updating the project, and that's like not possible with vibe coding. Yeah.
And then things like security best practices and whatnot. It's awesome for prototyping and for, an internal tool. But yeah, as soon as you get production grade, something that has to scale, it does have its limitations. One thing that I've been really impressed with is how you transitioned from philosophy over into this. Ty's got a background in biology, I've got health sciences. It really seems like having different ways of thinking helped contribute to the introduction to AI. So do you have any advice for someone not in the AI field, interested in getting into it, how they can make the switch?
Yeah, I remember 2 years ago summer, when I determined to like transition to AI, I looked up Twitter and I searched like AI thing. There's so many acronyms. Like I didn't know what LLM is at the moment. And I really I try to understand all the secret acronyms, and I was overwhelmed. How can I understand all of these things? And how these people are so knowledgeable? How can I catch up those people? I was kind of overwhelmed. I was kind of depressed, but it's not important. I just like figured out, okay, I'm gonna start from basics. I started with the Jeremy Howard O'Reilly book about AI, fast AI using AI. So yeah, if you want to start, like, don't dive into like those current state of our discussion. You will be discouraged and you'll be distracted. Um, if you have a math background, you will be it'll be easier, but ultimately you have to understand some basics. And I recommend Jeremy Howard's book, O'Reilly book. I think it was practical AI for coders. Yeah, but you can double check the title. And
Absolutely.
yeah, keep building and writing, and also the real like opportunity comes when you actually give presentation in a conference or meetups. I got my previous two jobs, right after I give a talk at the conference or meetup. And this is I think this is like a secret. You have to build something. You have to participate from hackathon. You have to, have your own knowledge and then share with people, and people will come to you. So like securing a job is I think a biggest concern for me when I was starting AI. If you want to get a job as fast as you can, like share what you learn in a public space. That's a effective way, I think.
I fully agree. And I've got a previous job from posting on Twitter. I've had equally positive experiences presenting public. So if people are too scared to do public speaking, which I still encourage to do, get out of your comfort zone. But just putting things online, like you said, write a blog, make yourself out there, demonstrate knowledge, and people are attracted to it. Minki, this has been phenomenal. I've really learned a lot. It's been awesome talking to you and getting your perspective. Before I let you go, is there anything you want the audience to know?
Yeah, I want to share my manifesto. So Agile Flow and I want to encourage people to participate in improving this manifesto. So manifesto has five clause right now. First, I simulate with humans before building. Second, I always account for the LLM's lack of good judgment and working memory. 3, I use LLMs only when it's necessary. 4, I think bigger, tweaking the specification of input and output to design flow more efficient. And lastly, I respect LLM and listen to them. So instead of blaming LLM for mistakes, I read all the prompt, I design the prompt to be more ergonomic, and I design guardrails, and I try my best to understand the LLM decision and output. Yeah, that's all.
It's been a blast. Really appreciate having you here.
Thank you for having me.
Thanks, Minki. Catch you next time.